Good afternoon, everybody. Can you hear me? Working good. Good deal. Well, we had a little bit of a conversation before I started here about the term on the title here, actually, nitrates, and I guess it should be nitrate. Is that correct, Dr. Snow? So, and forgive me, around the department we use that term pretty liberally, and I guess what we mean to say there is nitrate. And I'm sure I'm going to misuse it quite a few times here in this presentation. So bear with me there. Who's in the room? Are we all science major people? Science majors? Any lawyers? I can't see in the back there very well. One lawyer? Okay, we'll try not to make fun of you. Am I missing anybody else? Everybody's pretty quiet. That's okay. So we'll get going here, and please interrupt me if you have a question as I go. I think my talk's fairly short here, so we'll get through it pretty quick, but please interrupt me as I go with some questions here. So some of these first couple slides, I'm sure all you guys probably know this or have at least seen it before. In the state of Nebraska, there's 175,000 active registered groundwater wells. We think there's about an additional 95,000 out there that aren't registered. There's 96,000 active registered irrigation wells. The map there in the top shows all the active registered wells in the state, and the bottom map there shows the distribution of active irrigation wells in the state. And you can see in that, I'm going to try pointing to it here with the thing here, there's a little kind of red area there, I guess it's red on my screen, kind of in the Central Platte NRD, where there's actually over 16 registered active irrigation wells per square mile. So think about that, 16 irrigation wells per square mile. That's a heck of a lot of irrigation wells. I'm going to talk first about the clearinghouse that the university has quite a bit of involvement here into, and then I'm going to go in and transition into the community of Edgar, Nebraska. So the clearinghouse, and its technical name is the Quality Assessed Agrochemical Database for Nebraska Groundwater. Oftentimes we just call it the clearinghouse for short, so we don't have to say it. There's approximately 500,000 analysis in that clearinghouse, 241 agricultural chemicals, and as the name implies, it is an agricultural chemical database. So there's a lot of things like phosphorus, for instance, that wouldn't be in there. Uranium's not in there, things like that. So we're specific to ag chemicals. Typically we're talking about nitrate and a suite of pesticides that relate to those. There's involvement from several different departments at the state of Nebraska, both monetary and staff time, and then also through UNL, through the Conservation and Survey Division, Dana Devine and Colleen Steele administer the actual day-to-day operations of the database, getting the data in, doing the quality flagging and some of that stuff. The database was developed in the mid to late 90s, and then in early 2001 there was some legislation that went through that made the Department of Environmental Quality write an annual report based on some of the data in that database, and we'll get into some of that here in a second and look at some of the maps that come out of that. So who collects all the data that goes in there? By far the largest amount of data in there is from the 23 natural resources districts in the state of Nebraska. We're very fortunate in Nebraska to have those NRDs. I go to a lot of national conferences around the nation and talk about NRDs, and everybody's pretty jealous of what we have here in the state with our NRD system, with their authorities, what they can do, the regulatory authority, and also with their ability to collect taxes to generate revenue for the programs and projects that they do. There's some other folks, community water systems throughout the state all have to collect samples. The Department of Health looks at those and submits those on behalf of the water systems throughout the state. The Department of Environmental Quality, Department of Ag, and the university, through their special projects that they work on, submit those results. And then the USGS submits all their results to that database as well. So as the name applies, it is a quality assessed database. So Colleen and Dana have to go through that database, and they have to look at particularly where the data is coming from, meaning do we have information about the well that was collected from? Do we know where it's screened? Do we know how the sample was collected? Was there Q&A that went along with that sample collection? Was there Q&A along with the lab? Was there chain of custody and all that stuff? It all goes into this matrix, and then it gets assigned a quality level. So when you're looking at the data in the database, you can only look for the highest quality flag, or you can look at all the data, or you can kind of pick and choose your data depending on what you're specifically looking for there. This table here is out of a paper by Exner and Spalding, and if you're interested in how the database works and how it was set up and the kind of the national significance of it, that'd be a good paper to read to get into some more specifics of that. So here's the most recent nitrate concentration in the state of Nebraska here. That's about 25,000 wells that represents. So if a well was sampled 2 times or if a well was sampled 10 times, it's only going to show up as 1 dot in this map. It was the most recent sample. Some wells were only sampled once in 1974. They're still going to show up on this map. So all this data, talk about this nationally. A lot of states are envious of the database and all the data that we have in the state. I have a statistic here written down. If you add up the numbers and do some division, we have roughly a water sample, a nitrate water sample, from 9% of all the active, and we think there's 95,000 wells out there that are unregistered. So that comes out to roughly about 9% of all the wells we have a nitrate water sample for. That's pretty darn good. I don't think anybody would tell you that's 9% is a bad number when you're looking at this quantity of data. So the issue there then, let me get to that here in a second. The issue there then is sample frequency. It's hard to tell whether nitrates are going up or down if you don't have the same well sampled more than once, or you don't have the same well sampled 5 or 10 times to try and do a statistical analysis on that. It gets really difficult. So here are just some maps that I pulled, and the report that all these maps are coming out of, there's about 10 of them on the table down there. It's a report that we put out every year. It's the one that the legislature asked us to do every year. And these are just some selected maps every 5 years. But you can see every year how the sampling changes throughout the state. That is another bias of the data when we look at it and we try to do trend analysis. Every NRD has their own sampling schedule. Some NRDs, if the well's running and they're driving by, they'll stop and collect the sample and send it in, and that's their samples for the year. Whatever they drove by and whatever well was running, that's what there is. Some NRDs will focus on a certain township or something similar, or the west side of their NRD or the east side of their NRD. So it samples by NRD, and I think that's evident in the maps here, and you can see all the maps in the back of that report there if you're curious. So that's one of the issues with the report. The legislature also asked us to just generalize our nitrates in Nebraska. Are they going up or are they going down? And that's just really hard to do. The top chart there shows a trend line. It appears like it might be going up a little bit. Our statistics people tell us that we can't say that's going up or down or either way. There's not enough there to say that. And then, and that's just looking at the data on its own. When you actually think about then that we're probably sampling more in areas where there are problems, we tend to have higher sample frequency in areas of the state that have problems. That skews the data even more. So that's something to think about. The only generalization that we can say with all of the data in this database is that typically deeper wells have lower nitrate levels. And I think I don't think anybody could disagree with that statement. So in 2005, to try and fix this problem of doing trend projections, they came up with a plan. They picked 1,386 wells that they were going to try to get sampled every year, if not every other year. They were trying to get these on a good sampling frequency that we could then do trend analysis on just these 1,386 wells. They tried to distribute them across the state. They looked at make sure that we had wells that we knew construction characteristics, where the actual sample in the aquifer was being pulled from. The top map there shows all the samples, the map that we saw earlier, and then the bottom map shows just those 1,386, the most recent sample from those 1,386 wells throughout the state. So then the fun begins. We try to do trend analysis on that 1,386 wells, and we're finding even more problems. And if you think about it, groundwater isn't in 2D, which makes things a lot more complicated. There's stuff going on in 3 dimensions. The water on the top of the aquifers, presumably different than water on the bottom of the aquifer. There might be 2 or 3 aquifers. Things change as you go down. So that adds additional problems when you're trying to generalize stuff throughout the state. So the solution: more monitoring wells in distinct aquifers. Maybe we can make generalizations eventually if we get enough wells in distinct aquifers on a particular aquifer, or on the top of a particular aquifer, or bottom of a particular aquifer. And then also add sampling equipment to existing wells so that there's a better chance that those wells do get sampled every year. There's actually quite a few dedicated monitoring wells out there that NRD's owned, but they didn't have the equipment to go out there and easily collect a sample from those. They didn't have a dedicated pump in the well, or they didn't have the resources to go out to do some of that stuff. Let me back up here. So a couple years ago, we had some carryover money from EPA. I believe it was approximately $2 million. And we said, well, how can we best address this problem? And we had to address it pretty quick. I think we only had about 2-year turnaround time on getting the money spent, which always seems to be another problem. So we started out and we looked at just some general GIS spatial analysis stuff. We looked at where existing NRD dedicated monitoring wells were. That's the top left map there. The middle map is wellhead protection areas, so we're looking at public water supplies in the state. And the right map then is distance from Conservation Survey Division test holes. We kind of smushed all those together and played with a few things, and that bottom map is what we came up with. We took that bottom map then and we sent it out to the NRDs and we said, hey, we have an idea, we want to put in some monitoring wells. Here's our map, the green areas we think are where would be good spots or better spots for the monitoring wells. What are your local needs in your NRD? Are you interested in some new monitoring wells? And back and forth. And this is what we ended up with. We ended up with 37 new test holes, all drilled and logged by Conservation Survey Division, 27 new monitoring wells in 14 locations. That bottom map shows where the monitoring wells are, and there's a number inside each one of those circles. It's pretty hard to see, but most all those locations had at least 2 or 3 wells in the top and the bottom of the aquifer. A couple locations had 3 wells, trying to characterize probably 2 aquifers in that area. And then we also purchased pumps for all those new wells that we put in, and 87 additional pumps for pre-existing monitoring wells that were out there that weren't getting sampled because they didn't have pumps in them. So nitrates and public water supplies, the map here, the small dots that are kind of hard to see, the small gray dots, those are all the community public water supplies in the state of Nebraska. And then the different symbols represent different things. The stars are systems that are on quarterly sampling, which means that they have one well that is over 5, that's sampled over 5 nitrate in the past. So they're put on then a quarterly sampling schedule. They have to sample quarterly instead of annually, which is what all the other systems do. The octagon pinkish looking things are systems that are currently on an administrative order for nitrate, and the triangles are the systems that treat for nitrates, reverse osmosis, or ion exchange. So we're going to zoom in now specifically to the city of Edgar. The red arrows pointing to the city of Edgar. City of Edgar is a pretty small town, population 500. If you look at the bottom map there, most of it's all irrigated cropland. I can't picture any gravity irrigation. I believe it's all pivot irrigation, at least within the wellhead protection area. Alluvial sands and gravels in the High Plains Aquifer, approximately 100-foot depth to groundwater. And something to note here, and we'll get into this in a little bit, Hastings, Nebraska, if you follow the railroad tracks there to the northwest, up that way, Hastings, Nebraska is about 25 miles away. And Hastings, Marty Stange with the city of Hastings is trying some pretty innovative stuff, and that knowledge gets down to the city of Edgar, and they want to try that same type of stuff. So we'll talk about that here in a little bit. So they're borrowing, I guess, some ideas from the city of Hastings and wanting to try that out for themselves. The city of Edgar was issued a nitrate administrative order in 2005. So the water that they were serving to their citizens in 2005 tested over 10.4, which put them then on a course that a nitrate administrative order does. And the first thing that entails is doing a preliminary engineering report that goes out and lays out the different options that the community has to solve their administrative order. And then Edgar took a little bit of a different swing here and started doing some projects, and we'll talk about those. So that preliminary engineering report looked at the different options with 20-year operation and maintenance. They had water treatment, a new well field, and a Clay County regional water system. And what the recommendation here was from the engineer was to use the wellhead protection option as a means of operating within the guidelines of a nitrate administrative order. And that's a mouthful, so I have a slide on that. And what that entailed, and the reason I say that in past tense is because that's no longer an option. Nebraska was unique. Nebraska was the only state in the nation that allowed that. They had a waiver through EPA that allowed them to do that. So Nebraska was the only state that allowed that option. And since a couple of years ago, that is no longer available, at least to new systems, and the old systems is still kind of in limbo as far as if they're going to have to, if they can still utilize this wellhead protection option or not. The theory there is that you do BMPs on the land surface to naturally clean up the groundwater, and it's a good theory. Everybody just has to realize that it's going to take a lot of time, especially in Edgar's geology. In Edgar's case, 100-foot of ozone and probably some fairly large regional influences of nitrate. It's going to take some time. So there's different conditions. I'm not going to go through those that are associated with that. They do have to do some soil sampling to prove that at least they're not loading the wellhead protection area as much. They're supposed to show that the loading is going down in the wellhead protection area. The first project then that they did was a kind of a community-based planning approach. They had about $250,000. And I think the big thing here that probably was a pretty significant investment, but that did a lot of good, and this is just from my opinion, was that they converted quite a few gravity irrigated fields over to pivot irrigation. So they weren't putting on near as much water and not driving those nitrates down near as fast. They also put some land in no-till, installed some buffer strips, and did some urban BMPs and urban education. And they also did some ozone sampling. They sampled quite a few sites within the wellhead protection area, and particularly they focused on some sites that they thought might be point sources of nitrate. The second project that they did, they had about $150,000. They came back and they did some ozone resampling. I believe the next slide that I have shows some locations of that. They added an additional alternative to that original 2006 preliminary engineering report, and they updated the figures for that engineering report to current figures, current 2010-11 figures, which are outdated again. So the ozone resampling that they did, the map is hard to read. Roy Spalding and Shane Jensen with the university did this. They did both 2005 and 2010 sampling. The map there shows some of the sites that they sampled in. I think all of them are within the wellhead protection area. They came up with these charts then in their report that shows the blue lines are the 2005 sampling points, and the red lines are the 2010 sampling points. And I picked out the two I think that were maybe the most evident of what we would like to see in this. These are both barnyard sites, so you'd expect maybe a slug of nitrates coming down. In that left map there, there's this slug from 2005 that maybe is represented down here in 2010. Maybe not. Maybe that 5 years we totally missed that and it's screaming through that area. But hopefully some of the work that we're going to do will help address some of those transport rates. The same thing over here, the 2005s in the blue. Maybe this slug is down here. I don't know. All the other comparisons are this way and that way, and I guess in my mind, maybe kind of hard to tell exactly what's going on. We'll hope to look at that a little bit more closely and maybe even do some additional vadose work to try and figure out if we're doing a better job today than we did 10, 20, 50 years ago. Project 2, then the additional alternative, they wanted to put in a treatment wetland. They did an aquifer stress test for this, developed an additional groundwater model, and did a feasibility analysis for that wetland. The plan was to pump some of the higher nitrate water off the top of the aquifer, put in a treatment wetland, let it naturally clean itself up, and then infiltrate back down into the aquifer there. Here are the updated figures. Then they updated some of the costs to today's figures, I guess. So the treatment plant was $1.3 million, and remember, this is a town of 500 people, so that's a pretty good chunk of change for 500 people. Treatment plant's 1.3, a new well field's 1.5, and a regional water system's 1.6 million. The engineered wetlands 1.5, and this is a pretty good sized report, and they go into all the pros and cons of each. I guess my general opinion is that if they do get the letter from Health and Human Services that says that they have to go back, and they're no longer able to do wellhead protection, they're probably going to go into that treatment plant option. Here in this case here, it was a little bit cheaper than the others. Probably does have more O&M than some of the others, so maybe it has a larger long-term cost. But there's a lot less unknowns when it comes to that. A new well field is probably the cheapest if you can find decent water close. There's questions, whether that's possible. The only other option might be is if another community comes into the same predicament that's close by, a regional water system might be in the interest of both communities in that sense. So this report then kind of took a shot to the side on us, and it actually recommended pursuing what they called a dual pump option, and that's a kind of a borrowed term from the city of Hastings that's just to the northwest there, 25 miles, that Marty Stange, who did a presentation last year here, I believe, probably talked quite a bit about, and I have a chart coming up here that shows kind of the concepts of that. The third project is the current project that we're doing, $150,000, looks at some well rehabilitation, which is specific to sealing the annular space, and I'll explain what that means here in a second. Decommissioning public water supply well, and we're going to try to do some explosion abandonment on that, and I'll explain that. Do an aquifer study, do nitrates float, and on the ground BMPs. Originally we had a pretty good slew of BMPs that we were envisioning. Unfortunately, if you look at the picture there, it's a pivot turned over on its side. I believe it was early 2012, right after this grant got going. They had a tornado go through and quite a bit of hail. So it took all the crops out when they were pretty small, left a lot of nitrates tied up in the soil. So I think we worked together and said that maybe it's in the best interest to put some cover crops in with that BMP money to try and tie up some of those nitrates so they don't make it through the soil profile there. Okay, so we'll get into the rehab project then, the well rehab project. So the grout task force study was through the university in the early 2000s, and I guess the conclusion of that is that the grouts that are in our standards aren't doing the job. The grouts that seal the annular space, the gravel pack, the space between the the well casing and the drill hole isn't doing the job that we thought they were doing. So they did a report on that, changed the standards. We think we have good formulas now that are protective of the aquifer. Other states are copying what we're doing, on and on and on. So then the question is if there's all these wells out there that were drilled to old standards and those aren't working, and then we have wells that were drilled without any standards at all, gravel packed all the way to the surface. Gravel's a great conduit for contaminants to get down to the aquifer. Is there anything that we can do with these existing wells to upgrade them to current standards besides decommissioning them and drilling an entirely new well, which costs quite a bit? So the thought was, is there some way that we can seal the annulus off? So in Edgar, there was a plan for how we would do this. Everybody thought it was a good deal. In Edgar, that left picture there, we're installing some monitoring wells right next to an irrigation well. There's the irrigation well. We did 3 of those, and the plan was to upgrade those irrigation wells to current standards. The way we would do that is we'd put a cutting tool like the one in this middle picture. We'd go down the borehole. We'd figure out exactly where we want to place that seal. Is there a clay layer in there that would be a good spot to put it? Should we put it right at the top of the water table? And then we'd perforate that casing, and then we'd put a packer in, which is on that right picture there. That's just I guess it's a fancy balloon on the top there, and on the bottom is another fancy balloon. We'd inflate those balloons above and below where we just cut those slots, and then we'd squeeze a grout in between there. So here's a little bit better picture of that. This rocky area here kind of demonstrates the gravel pack. In this case, there is a surface seal on this, but it shows how that packer sits in there, and then they squeeze the mud out into the annulus and hopefully plug that up so that contaminants can't come down. This is how they're trying to, it shows some sight glasses, some dye tubes and stuff like that. So this is kind of a diagram of how they hope to monitor whether this works or doesn't work. But at any rate, so in Edgar, we got the cart before the horse. They're doing this, here you can see the red arrow there. If you look at the casing, that's transite casing, which they no longer make, but somebody can probably correct me, it's asbestos and maybe concrete mixed together, fairly strong, fairly thin. So makes sense to start with that because it's strong and thin, and it's probably the easiest to cut through and the easiest to work with besides the asbestos factor. So successfully they've proven that they can cut slots in this and squeeze grout into the annulus in transite casing. Unfortunately, in Edgar, all the irrigation wells are concrete cased. So that kind of adds a new dimension to the problem. We've never tried cutting concrete, I guess at least that we know of. In fact, they're currently trying it, or last week they were supposed to be trying it, kind of doing a bench test. But we've never actually done it inside a well. Can we cut the concrete without the well collapsing? And then can we inflate the packers with enough pressure and squeeze some grout into the annulus? So unfortunately, I guess for this funding cycle of money with the city of Edgar, we got the cart before the horse. And that has worked in favor for a few other things, and we'll talk about that here in a minute. The explosion abandonment, they have a few old public water system supply wells. One is actually inside of the old courthouse, and the plan is to go in there, explode the well out, and what that would do is, you can see that left picture is a cable with some charges and some ball bearings wrapped around it. They lower that down in the well, and they put those charges where they think they have a clay layer, a natural clay layer in the aquifer, and then they'll put another one right at the top of the water table. They'll fill that well full of concrete after that cable and charges in there, and then they'll blow it up. That then sends those ball bearings through the sides of the well, forces the concrete slurry into the annulus then, and effectively decommissions the annulus as well as the well. These pictures are from Chester, Nebraska in September of 2013. Here's another picture. That left picture is after when they have everything set up after the charge is actually blown, and then you can see what it looks like. They said you can't really feel an earthquake or anything. The only thing that you can tell is that the concrete splashes out a little bit, and then it sloughs off several feet, so they have to top the well back up. But I think this is something that if it goes right, and they're looking at monitoring whether this is actually going to work. We're going to try that in Edgar. We're going to put some monitoring wells and some dye injection tubes next to the public water supply that we're going to decommission. If we have success here, I think that eventually this procedure will make it into the rules and regs for water wells throughout the state. This is back to Marty Stang at Hastings, his dual pump study. What he looked at is siphoning high nitrate water off the top of the aquifer, and then utilizing the low nitrate water that's in the bottom of the aquifer, and distributing that out to the citizens, and it'd be under the 10 parts per million there. So here's just a graph that shows some of his results from that, and he was able to do that in this test here. He since, I haven't heard the most recent, but he's trying to ramp that up with larger quantities. He still has the issue, just like Edgar or any other community would, of then what do you do with that high nitrate water after you pull it off the top? You have to do something with it. You have the capacity to put it in a lagoon and store it and maybe utilize it for ag irrigation in the 3 months of the year that they're irrigating, and use it that way. You can't dump it down the river, and most municipal treatment plants can't handle that quantity of water that would take to actually make a difference in a public water supply system. Here's another example of that. The left picture just shows 2 different pumps in the well, pulling the high nitrate water out of the top and the low nitrate water out of the bottom. So the city of Edgar heard about this, and Marty Stang does a good job of spreading the word and telling his successes and trials. And they picked up on that, and they said, oh, well, we want to take the well out of our municipal, or we want to take the pump out of our municipal well, and we want to put 2 pumps in it. We want to replace it with 2 pumps, one on the top of the aquifer, one on the bottom of the aquifer. We'll pump the top one into the creek, and the bottom one we'll send to our distribution system, and will magically be below 10. Actually, it sounds like a pretty good thought. But we thought, well, now before we spend $100 and some thousand doing that, do we even know that water in the top of the aquifer is higher nitrates than water in the bottom of the aquifer? It is 25 miles away in Hastings. Is it in Edgar? So we said, well, let's put in some nested monitoring wells next to your public water supply well. So we did that, put one in the top, the middle, and the bottom of the aquifer. Here are some of the first results from that. It doesn't matter if I tell you what the colors are, because it doesn't make any sense anyway. But essentially what we found, we don't know what's going on there. Some weird things are happening. The opposite things that you would expect to happen when that well kicks on, or when it's been sitting idle for a while as far as water levels go. So there's some interesting things that are happening there that we hope that we can look into, and we don't know if there's maybe more head in the bottom of that aquifer, has some more regional influences. We don't know what's going on, but it's deserves some looking into. I think it does answer the question, though, would a dual pump option work for the city of Edgar? And I guess the take-home point here is that all the samples are above 10, and these are very low volumes. So no, a dual pump option probably would not work, at least in this well for the city of Edgar. So the Aquifer Study then, I mentioned that the well rehabilitation project then is not going to happen, at least with this grant cycle of money. So it left a little bit of money left over. We had originally planned to do some age-dating tritium and helium on the 3 nested wells that were close to the public water supply well. And we're going to work with Dr. Snow and Nathan Rodney as a grad student. And we're going to ramp that up and do quite a bit more sampling from throughout the wellhead protection area, do some ions and some other stuff. And Nathan's going to try and look at some of this stuff and make sense of what's going on. So the city of Edgar, we've gone through from their nitrate administrative order in 2005 to current. Will they be able to continue to use the wellhead protection option? I don't know that at least I can't answer that, and I don't know anybody that can or that will give you an answer. So the city of Edgar is kind of hanging back, I guess, and waiting to see if they get that letter or not. And that has a little bit of effect on what they do. Hopefully they'll still try to keep doing the BMPs and the on-the-ground management practices, I guess, as we would hope that would happen throughout the state. Unfortunately, they don't have to pony up $1 million or $2 million to put in a treatment plant. That's all I have. Do we have any questions?
With the age dating, was that just for source tracking?
Can I pass that to Dr. Snow?
Age dating would be to determine when recharge occurred, so when the water intercepted the water table.
Both the year and the season, correct? Both the year and the season? Yes.
One other question I had, you mentioned that they might just sit back and wait and see, but I heard earlier that they were over the 10 limit already, so I was wondering what options they have for the meantime while they wait.
Right. They are, and through that historic agreement with the Department of Health and Human Services, with the Nebraska Department of Health and Human Services, they're able to still serve water to the residents between the 10, and I think they can go up to 14.5. Once they hit 15, then it kicks out that wellhead protection option. They still have to serve water to pregnant women and babies, bottled water, and I don't know if I think they have a contract with a water service to haul in bottled water to those that request it. So.
For folks that use the ion exchange procedure to clean up the water, what do they do with the nitrate?
Since you have the microphone back, Dr. Smith.
The brine, yes. So the resin has to be recharged. So where would that go?
So McCook has an ion exchange, and they have a deep disposal well that they put it down, a class 1 disposal well. And off the top of my head, I can't think of another community that has an ion exchange system. Of course, up in Crow Butte, they make uranium with it. So
yeah, so it can be discharged to surface water, or you can swap out the resin and have it discharged or have it reconditioned somewhere else. But yeah, there is the problem with disposing of the resin.
I believe McCook, the reason they had to do the deep disposal well is because they didn't have the quantity, the dilution factor when they were doing that to dispose of it in the river, is my remembrance of that.
I'm wondering if you would comment a little bit. I know some of the cities or towns out in central Nebraska have had some problem with arsenic and so on. And like I know Arcadia has like 37, but the people have lived there 200 years and kind of wondering if they ought to go to $3,000 per person to treat the water or not.
Right. It's natural. Might be liberated from Dr. Snow. It's naturally occurring in that area. Yeah. And is it maybe liberated by some practices on the surface? I don't know. So there's options for them along with Edgar to go through some state and federal financing options to do the treatment that they need to, and that's all based on some calculations, and they look at some residential water rates, what that would put you up to, and then there's some criteria that I don't know where they get this number from, but somehow your residential water rate shouldn't be averaged over this much a month, and beyond that, typically in the past, my experiences is that grant funds, federal grant dollars kick in then to kind of cover that extra expense. But definitely the community of Edgar, if they get in a situation where they have to put in treatment, their water rates are probably going to go up to $50, $60 a month. I think that's pretty typical. And then beyond that, if the project is that much more, I think federal dollars usually kick in to cover some of that. Now, I don't have I can't say to your specific example there or not. Go ahead.
You mentioned that there are approximately 95,000 unregistered wells. So how do the natural resource districts account for this, the pumpage of water from these unregistered wells?
How does who account for it?
How do they monitor the water level being pumped, the amount of water being pumped from these unregistered wells? By the end of the day, they have to see whether
Right. So most of those wells that I said are domestic wells, low capacity domestic stock wells, to that order. When an NRD, for instance, gets into particularly a quantity management phase, meaning they go in and they start certifying acres, what happens is it's now a state law that all active irrigation wells need to be registered. So when they go start certifying irrigation acres and start looking into the regulatory process of restricting quantity, usually it picks up a lot of those old wells. I'm familiar, family has that same situation. There were some unregistered wells that we didn't know about. Well, they were out there, but a lot of people just don't realize that their wells are not registered or that they're supposed to be registered. So usually then those get picked up, and eventually we'll hopefully have all the wells in the state, most all the wells in the state registered. And as new wells are drilled and decommissioned, it's a slow process, but it's happening. So, and I think from a national perspective, I can't come up with another state. Some states don't even require registration. So, and some states it's up to the individual county. So, it's kind of a mixed bag of worms. But I think here in Nebraska we're pretty fortunate with what we have, and we keep trying to improve what we have. So,
you said that you are replacing the concrete well casing with the asbestos well casing. Do you think that 100 years down the road you'll be having a problem of removing the asbestos from the groundwater, because generally asbestos is carcinogenic?
Right. Well, we're not replacing them with the asbestos. So I think as we look at and I'm not a well history guy, but originally we started out with concrete, and then the transite casings kind of came into play. They were easier to work with, easier to install. Those were kind of the main thing. And a lot of this depends on your location within the state and the nation too, as far as I believe those transite casings were actually made in Hastings, Nebraska, so which is probably a reason why they're prevalent around the Hastings area. Or maybe I might be mixing up the concrete with the transite, but at any rate, it's regionally, and now most all the wells are steel or PVC, some type of plastic now.
I had a question. You started out talking about the clearinghouse and mentioned that it was agrochemicals. And has there been any talk of adding other contaminants that are impacting public water supplies to the clearinghouse database?
It's been thought about, but I don't think too seriously. I think that'd be great data for us to look at. Uranium and arsenic, and especially some of those major ones. But yeah, maybe it's something that we should be talking about more. And maybe that isn't the exact place to put it. Maybe it's a side separate database. But I think generally the structure of that database and how that database works it is, a good structure to follow that could be utilized with arsenic and uranium and whatever we're concerned about. So.
Hi, Ryan.
Hi.
My question has to do with the abandonment of the annulus that you mentioned on some of the wells where we're injecting to seal off zones of confinement. How are they going about verifying where those confined layers are? Are they going off the original driller's logs, or are they drilling a verification well nearby?
Yep. Right now we're drilling a verification well next to the existing wells. Now, once this makes its way and perpetuates itself into the mainstream, meaning that this is what we do with these wells, is that going to be required for every single well out there that we want to retrofit? I don't know. That's a great question, and maybe it's a simpler geoprobe going down and figuring out where some of those clay layers are. I mean that seems a lot easier than hollow core augering a well in next to it. But that's a great question. It's going to be expensive, but I guess the goal here is to make it cheaper than it would be to decommission all the wells out there and redrill new ones. So. And
got a question about just farming practices, and I seem to recall that the Central Platte NRD has pretty much required certain farming practices, no anhydrous application in the fall, that sort of thing. But also, are they not, in some of these NRDs, basically saying, given the nitrates in the water that's being applied through pivots, that you have to, make adjustments in terms of nitrogen application? And is that working? And if so, why isn't that done more universally?
I think the Central Platte is a great example, and in Nebraska, the Central Platte's our success story. They started doing management practices, boy, it's been a long time ago now, 25-ish years ago. They came into some of those phases that had some of those requirements built in, and they've seen the spike start going down now. So they're obviously in an area of the geology and aquifer that's a quick response. So I think, in that case, I don't know that you can pin it to one specific practice, but, it's the suite of practices is doing something, and in their practices, and I don't know if the Central Platte NRD specifically does, but they all have nitrate budgets or equations that they go through, and one of the things that they're supposed to account for is the water that's being pumped through there. Now it depends on what NRD you're in and what area specifically you are in the NRD as far as whether you have to actually follow those results that you get from the end of that equation, or if that was just an exercise of your hand in the paperwork and the calculator. But that is something that we're trying to look at a little bit more closely. Some of the recent rules and regs that I've seen, a few NRDs had their own equations out there that utilized groundwater, that they're irrigation water, I guess, that go into the equation. And at least the two that I've seen recently that had that in there, that had their own equations, they went back and are now using the university's equation. So the university has an equation that's supposed to account for that, and then it just varies between the NRDs as far as whether you have to have last year's water sample, who has to take the water sample, if it can be the average of the past 5 years water sample, or how old the water sample can be, and there's always ways of cheating the system, but I think we're doing our best, and we're trying to get better as we learn from the past. So.
I noticed on your map of the administrative orders that was really somewhat encouraging, because I think I remember there was a time when there was as many as 19 communities or something that were on administrative orders. And I guess I'm just curious, Are most of those off due to some sort of treatment process, or have you seen some of these communities where actually wellhead protection has brought down those concentrations?
Most of them have gone to treatment or hooked up with another system or drilled a new well, something to that sort. We're hoping that Edgar is going to be our example. It just hasn't materialized yet. There is in the southeast corner of the state, one of the rural water districts that has seen some impacts on a positive, meaning they've been doing wellhead protection. They've been under the wellhead protection option for a while, and their nitrates are slowly going down. They recently just paired up with another water system, though, and did a joint well field between the two. So they're now not on a nitrate administrative order, but not particularly because of the wellhead protection option. So, and that might be some of the reason why EPA is not liking it, because we're not getting those instantaneous results that everybody likes to see.
All right, well, I think we're about out of time. If you have further questions, Ryan will be around for a little while. We also have some reports and brochures if you're interested that cover some of the stuff that he talked about. Let's thank him for his presentation.
Thank you.